now we're on to the transformer testing part of things. So, and another thing I just was kind of thinking about was, if you recall, I built the turret board out of sequence to what the build documents say. Same thing with the testing. The testing that we just did on the turret board would actually be coming after what we're doing now. But because I built that ahead of time and out of sequence, all of that testing we've, of course, done now. There are basically 3 steps to checking the power. The first one is with no power. We take the bulb out of the amp. We take the fuse out, and then we're just going to verify that none of the secondaries short to ground. The first part of the power testing is to test everything before it's wired into the circuit. I already have wired everything into the circuit. I tested the transformers before I put them in. Basically what you do is you're checking your secondaries to ground and just making sure that you don't have any direct shorts. A very low reading is good. Direct short reading means you've got a problem. I don't have that with these transformers. So we're going to move on to step 2 of the power testing. In that, what we're going to do is everything will be connected to the board except the high voltage secondaries, which, as I've said, they're not connected right now. All the rest is connected where it's going to go. There are no tubes in, and we're going to put the fuse and the pilot lamp back in, and then we're just going to do a little jump test. Just a quick 1-second test where we turn it on and off just to make sure we've got voltages here. So let's hope we don't have too much excitement. And we're going to make sure the amp is turned off. I've got the power cord plugged in. I've got the amp switch in the off position. We're going to switch the amp to standby just very quickly, just to see that the lamp goes on. And the amp is turned off, so I don't have the switch in the wrong place or wired in backwards. What we want to do is just flip this on to standby, not full power, and then off right away. We just want to make sure that we get a bulb. And we're good. We've got a bright light there, so we turn it off. That means that our 6.3 volt secondary and our wiring all across is working fine. One thing that I didn't check before that we will check now when I was checking continuity was the connections of the heater wires. So I'm going to unplug this power for a minute, and we're just going to double check that the heater wires run, because what happens is the 6.3 volt secondaries come in here, connect to the bulb, both sides of the bulb, and then your heater wires come off of there. They go around, they go to the appropriate pins on the tubes, and they should go in a daisy chain all the way through. I should find all the way here at the end where the effects loop is. Actually, there's wires going to the relay board as well, but I'm not going to check there. I should have continuity black to black here and red to red here. If I get continuity all the way through there, we can assume that all of the tubes have their heaters connected properly. So set this back to continuity. I'm going to put one probe on black here and one here. We should hear it. And we're good. We're good all the way through. Here's so the red to red. We're good there. Let's see if I can get red here. Yes, I can. We're good there. I just noticed down here on the relay board, this black wire for the heater seems a little bit close to the bolt for the standoff, so I want to make sure we're not shorting anything to there. Okay, so we've checked the lamp. So I'm using my notes just because I don't memorize everything. We've got the pilot lamp and fuse in there. We switched it on and we got a good bright light. What that tells us is that the 6.3 volt winding is not shorted. If it was, we would have blown the fuse and we wouldn't have had a light. If we had started this and there was no light, the first thing to check would be the fuse. It doesn't mean that it's not working. It could be that we got a bad bulb. We didn't have that problem, but if we did and we had no light, we would check the fuse. If the fuse didn't blow, we would try a different bulb. Then from there, hopefully everything was fine. If the fuse blows, it means there's a short, so you would want to check your wiring. But if your fuse is holding, that's a good sign. We're on to step 3 of the power testing, and this is where we need to be really careful. So I've still got the power cord unplugged. I'm just going to set it aside for a minute, and I'm going to connect our secondaries up. Our secondaries will connect to either side of the rectifier. So that's these diodes here. So we will connect one to this terminal, and we will connect one to this terminal. And no, we're not going to connect them. The first thing we're going to do, we're going to connect our voltmeter across the secondaries here and make sure we're getting the voltage we should see. So that's the first thing we're going to do. We should get about anywhere from 700 to 840 volts AC. And I'm going to run these wires so they're away from me. Okay, so we're going to power this full on, just long enough to see what voltage we get. And I'm getting about 710 AC there. That's actually a good sign. If I turn this to full on, yeah. So I'm seeing about 700 volts AC there. Turn this off. So it looks like the power transformer is good. We'll solder those secondaries in, and then we'll start checking some of the working voltages. They go to each end of the rectifier here. We'll start with this turret because we only have to put one wire in next to that diode. We've got 3 wires going in this turret down here, so we might have a little bit of a fight. I like to put a little bit of flux on there, even when I'm trying to desolder a connection. I just find it allows the heat to flow a little, or the heat to get in there a little better, and I have a better time getting the solder out of that connection. There we go. So we bring yeah, that's that one. Let's see if we can get both these wires in here. Okay, it's tight, but all those wires are sitting there. And so when you're doing this, you want to, it always happens that you have to unsolder something because you need to add another wire in, but whenever you can, if you can plan ahead and make note of which turrets you're going to have to add wires in later, and maybe just don't solder those ones at that time. It'll save you from this kind of trouble. No harm done. Everything's looking good there. That's a good solid connection. Next step that we're going to do, we're going to hook up the VOM again, and we're going to check that our voltage, that we go to full voltage here. So we set to 700 volts AC. We are going to connect our leads. And we want to watch and see what our voltage goes to there when we power it up this time. And we also want to watch for sparks. So if this goes well, and the fuse doesn't blow and nothing else blows up, we have an amp that's ready for tubes, and we do. We're at, we've got 708, yeah, we're about 708 volts AC across the secondaries, and that's what we should be seeing there. The lamp is nice and bright. Everything is looking good. I can even see the tube in the effects loop, the heaters are running. That tube's lit up, so that means that our 6-volt heater supply is definitely getting at least as far as this. It should be at the relay board as well. I can't see the there is an LED on the board under there. I don't want to get my face in too close here. So it's looking good. We've had this sitting here for what, a minute, 30 seconds. Our voltage is holding steady there. That's of course AC. And everything is looking just ducky. I'm going to power this down and we'll get ready for the next round of tests, which will basically be voltage tests through the whole thing. Okay, give some time for that power to bleed off, because now B plus did charge up here, so there are some high voltages in there. That should be good for now. Always make a habit to remember to unplug your power cord when you're going to go back into working on this. That's all good. We're looking really good right now. I'm going to stop the recording right now and load all the footage that I have so far and just do a little review of what I want to do next. What we will be doing is checking voltages at all the tube sockets, all the various test points, making sure those voltages are where they should be, and then I will put some tubes in it, and we'll make sure it's making a little bit of static or hum. You'll always have some. So stand by, we'll be right back. And now it's time to do the final testing, find out what this amp is made of. So I've got my notes here, because of course it's a lot of things to remember, and you should have a checklist for everything so that you make sure you get everything checked off right. So we've already done the power up tests. Nothing blew up, nothing went south. One thing that we're going to do now is we're going to just do that last power up test again. Tubes are not in yet. So I'm going to just plug it in, make sure our high voltage secondary is still going to about 700 volts AC. Make sure the pilot light comes on, make sure everything's okay there. If that looks good, we're going to power it down and we will start looking at B plus before we put the tubes in. I think, as I said before, I often stand up doing this. I don't know why. I'm not as comfortable doing it sitting down. I'm going to do it sitting down for this because you don't really want to look at my stomach while I do this. I like to kind of run it so that the power cable is not really in the way anywhere. I've got a lot of things back here to get tangled up with it, so I'll try not to go too far there. The other thing is I can just plug in and unplug the IEC connector, and you know, it makes it really quick and easy. So we've got the meter on. We're set at 700 volts AC. We're hoping to see about 700 volts there. We will power this on to standby, and yeah, right away we get up to about 7.5, 7.8. Pilot lamp is bright. Everything's looking good. Nothing's smelling bad. Nothing humming or smoking. So we watch that. I just turned my soldering iron on, so I'm smelling that, but okay. Flip it off of standby. And we're still at 7, we're holding steady, about 708 volts. Everything is seeming good here. I'm going to take a look at the heaters with my fluke. Make sure we got 6.3 volts AC. Actually, without tubes, we should be closer to about 7 volts AC there. These old fluke meters are real war horses. They will go forever. So you just have to remember that you've got some specific settings you gotta make for them. They're not auto ranging. Transformers are staying cool, which is what we want. That's one thing. Without tubes in, and we're doing this testing, the OT should stay cool the whole time, because it's providing some current for the lamp. It will draw a little current through the power transformer, and so it could get a little warm, but you don't want them to start getting very warm. So let's just see what we've got. Okay, yeah, we're at about 6.7 volts for the heaters. That's about right. There's no tubes in there yet. We do have the one tube in the effects loop, so it is drawing a little current. Let's just check what our voltage is there. It should still be about the same. And yeah, we're at about 6.62 volts there. And back over here again. Yeah, 6.66 volts. So we're good. We've got the polarity right for the heaters all the way through. Everything's looking good. I'm going to power this down. The amp has bleeder resistors, so it will bleed off the stored charge in the filter caps. But we want to give it about a minute to do that. I love the older gear when it still works. It's just I don't know. I think I did a midweek musing video a while ago about using older tools and equipment, and just kind of thinking about the people who have used it before. Okay, so we should be good. The high voltage should be down. So we are going to check our B plus now. So this is going to be DC voltage. So we want to set our meter to DC. And we are going to check B plus to ground. So I'm going to leave this one clip on. And I'm going to clip to the power supply ground here, because we're checking B plus. Okay, so we're going to set the bias supply full anti-clockwise at full negative, so when we put tubes in we won't be red plating, hopefully. Now we're going to check our B plus. So we're going to start by checking the plate voltage at both of the output tubes, pin 3 of both of the output tubes. We want to make sure that we see about 40% above what the raw AC was. So we had 708, 710 volts raw AC across the entire secondary. Of course, there's a center tap here, so the each side will be about half of that, 350 volt raw AC. You add 40% to that. We're looking for about 490 volts DC without tubes, and we're looking for it at from ground at pin 3, the brown wire on this output tube and the blue wire on this output tube. So we will fire the amp up. We should have our B plus. We will take a reading here. And yeah, we got 460, so might be a hair low. We'll see what happens. And over on here, we've got, yeah, we got 460 both sides. So yeah, we're at about 32% up. That might be a little low. If things don't get hot, I'm not going to worry too much about it. These things can be within a range. So yes, we've got unloaded. We've got 460 at the plates of each tube. We'll also check what voltage we have at the screens at pin 4. So yeah, we're seeing 452 at pin 4. And that's good. So it should be just a little bit lower because we got those screen resistors in there. And now we'll check the negative bias supply. It will be DC and it should be negative. Okay, yeah, we got minus 34.7 volts grids, minus 34.7. So we're good with our bias supply. In the KT66 position, we got negative voltage of maximum negative voltage of 42.6. In our 6V6 position, we're at minus 30, well, it's gone up just a little bit. We're at about minus 36. Minus 35, minus 36, plenty. So we're good there. So we're getting down to the last page of notes. We can power this down. I'm going to let it sit for a couple of minutes. It's been on long enough that if the transformers were going to get hot or warm, they would be. And no, they're good. We're going to put the tubes in, and we will check all of the voltages again. Of course, with tubes in, you never should fire up your tube amp without a load. A solid state amp, what's dangerous for it is to run into a short. So a lot of solid state amps, you don't want to go less than 8 ohms because that gets too close to a short for them. Tube amps doesn't want to go into an infinite resistance, which is an air gap or nothing plugged in. As long as there's no signal, it probably will be okay, but even a crackle or a static release will cause that to send a signal through the amp. And when it gets to the end of that transformer, the secondary, if there's an air gap there, it's going to essentially act like a solenoid in a car, and it's just going to arc, and that will cause damage inside the transformer. It might not kill it the first time, but it definitely over time would be tough on it. This is why the older Fenders have a shorting jack. They have the speaker jack, and then they have what they call the extension speaker jack. The idea is that you would be plugging into the speaker jack, not the extension jack. If you unplug that jack shorts hot to ground, and the reason is that's not as hard on the output transformer if a signal were to go through there as it would be if it were open. You still shouldn't run that way, but it's a little bit of a safety. It probably won't destroy your transformer. If it ran into that short briefly, your tubes could run away. Your output tubes could probably red plate, and that could cause some other kinds of damage. But the idea is that, you know, if there's no sound coming out of your amp, you're not going to sit there going, hey, what's going on, what's going on? The idea would be that you shut the amp off right away and check why you're not getting signal. I have a little homemade dummy load that I made with some 100-watt 8 ohm resistors. I have 2 in parallel here, which gives me a total 4 ohm 200 watt dummy load, and these two are run in series, which gives me a 16 ohm 200 watt dummy load. I think at one point I had a switch on here so I could switch this so that I was just running one of the 8 ohms at 100 watts. So I'm going to use the 16 ohm side of my dummy load, and I've got the impedance selector set to 16 ohms. I'm not going to put the shields on because one of the things we need to do is a visual test. And what we mean by that is that we want to make sure that we're getting the filaments are lighting up, the tubes are not red plating. You know, we want to see that everything is copacetic. So one thing about red plating, people, you know, they install the tubes in an amp and they turn it on and they see the orange glow. That is normal. The orange glow is the heater filaments themselves. The tube cannot operate without that heat, and those filaments, you should see that orange. What they mean by plates going red plating, and it would be very rare to see it, I think, in preamp tubes, but what you want to watch in your output tubes is that the plates don't get red. So the plates are this gray structure you can see inside. The heater is inside. If you see through this little square here, you see red through there. That's normal. That's the heater. Sorry, you might not have seen that. This through this little square. If you see red there, that's the heater. That's normal. It's the plates. It's this gray outside plate. If these start glowing red, you've got a problem, and that's what you don't want to see. So, wow, these new sockets are really stiff. There we go. Good. means the tubes won't fall out. Okay, so that's my last JJ6V6. So I'm going to, I have a match set of Mesa Boogie 6V6 STR tubes. We'll put those in there. They're a match set, so that at least is good. And these are black, so you won't really see, you can see through the top, so I should be able to see what's going on in there. We'll watch the voltages and current to make sure we don't go crazy. Also, if the pilot lamp goes really low, we know we're drawing a lot of current, so let's just get rid of that. And for preamp tubes, I've got a couple of, I've got 3 Electro Harmonics 12AX7s, and I've got a Groove Tubes 12AT7 for the phase inverter. So we'll put that in. Don't know where that came from. I don't recall the last time I bought anything that said Groove Tubes. Nothing wrong with them. Wow, these are really great tube sockets. Nice tight fit. Make sure I've got no bent pins. So I've got those Boogie 6V6s. I've got the Groove Tubes 12AT7 for the phase inverter, and then I've got 3 Electro Harmonics 12AX7s. We will turn this back over and fire it up, and hopefully everything's still happy. Fire it up on standby first, see what we get. Make sure we're getting all the lights we should get. Just going to turn all the lights off for a minute, make sure we've got heaters coming on here. Okay. It can be really hard in some of these to see the heaters, whether they're lit. Yeah. Okay, looks like we got heaters. It's honestly not a bad idea to have a set of blackout curtains so you can get your room really black. Some of the, in particular, the 12AX7s and 12AT7s, it can actually be hard to see if your heaters are lit. They are. I can see them. That's all fine. Okay, so I've got the dummy load connected, 16 ohms. I've got the impedance selector set to 16. I've got the 3 Electro Harmonics 12AX7s in V1, V2, V3. I do see that the heaters are lit. I have that Groove Tubes 12AT7 in the phase inverter, and I can see that the heater is lit there, and the heaters are lit up on the 6V6s. The transformers are still cool. There's warmth coming from all of the tubes, which is good. That does mean that their heaters are working. I'm on standby right now. We're going to go ahead and throw this into play mode. No smoke. Everything seems fine.